everyone, my name is Sakshi. In this lecture, we will be discussing about our 100 MCQs for Discrete Mathematics Semester test students. Okay, so let's start from the question number 1. Question number 1, we have integer and multiplication forms. You know it, okay? Question number 2, we have which of the following is an infinite group? Infinite group is set of integers, okay? Question number 3, we have a cyclic group is always a real, okay? Order of finite group means number of elements. Okay. Kernel is associated with homomorphism. Cosets are formed using subgroups. Okay. A ring with multiplicative identity called unit ring. And ring basically follows two properties. First is addition, second is multiplication. Okay, additive and multiplicative property. It's mostly okay. Every field is a ring. Okay, but not vice versa is true. The negation of true is false. The contradiction is a statement which is always false. Okay. This is the biconditional symbol. Okay. If P is true and Q is false, then P and Q is false. Okay. If P is true and Q is false, then P or Q, or we also call O as the disjunction, okay, then would be true. This work as a this will work as a addition and is work as a multiplication, okay. Conjunction and disjunction call. Implication P tending Q is false when P is true and Q is false, okay. The law P disjunction negation of P is called what? Excluded middle law. Okay. Predicate logic is stronger than the propositional logic. If for all x P of x for all means what? Every. Okay. Which graph has no edge? Null graph. A graph with one vertex and no edge is called what? Real graph. Okay. Adjacent vertices are connected by edge. The degrees sum formula is based on handshaking lemma. Okay, handshaking lemma says that sum of all vertices, sum of degree of all vertices is equal to 2 into number of sum of all edges. Okay. A loop contribute how much degree? A loop contribute 2 degree. Okay. Parallel edges are allowed in multi-graph. Which graph can be colored using two colored building? This is called bipartite graph. Okay. K3 is an example of complete bipartite graph. Okay. A walk with resistive vertices is called paths. A closed walk with no repeated edge is called circuit. Okay. Closed path means circuit. Okay. The shortest path between two vertices can be found using Dijkstra algorithm. Okay. In a connected graph, every pair of vertices has a path. Next question: the complement of a complete graph is a null graph. Okay. Euler circuit uses every S once. An Euler path exists if graph has exactly 4 degrees. Okay. Here it is discussing about the path now circuit. Okay. A graph containing Euler circuit must be connected. Okay. Question number 34, we have Hamiltonian circuit visits every vertex at once. Okay. Which problem is in NP hard? That is called traveling solve problem. Okay. Flurries algo avoid what? Breezes when possible. Okay. Breezes means edges. Breezes is edges actually, but this is cut edge. So NS is called bridge if you remove it and the graph become disconnected. Okay. A tree is minimally connected. Okay. Removing one edge from a tree makes it disconnected. Okay. This is called the disconnectivity and connectivity. If you use connectivity, so that means that create actually a cycle. Disconnectivity create a forest. Okay. So adding one edge to a tree creates cycle. Okay. Every connected graph has at least one spanning tree. It can multiple spanning tree. Okay. You can find out it using formula as well. Okay. Fundamental circuit are formed by adding edges to spanning tree. Okay. Prim's algo start with vertex. Kruskal algo select edges based on the minimum vertex. The spanning tree of a graph with n vertices contain n minus 1 edges. Okay. A disconnected graph cannot have a spanning tree. Okay. Because for the spanning tree, it's important to be a graph connected. Okay. The center of a tree is related to radius, diameter, and distance. All of these. Okay. The eccentricity of a vertex is maximum distance from one vertex. A pendant vertex has degree. Madam, I will come. I will learn. Whereas again, the question that I covered is this question. At least once. Okay, okay. Here we will be discussing about the Calais theorem. Okay. Here we have to discuss about the Calais theorem. Okay. Calais theorem says how many spanning trees a tree can contain. So this is called T base n equal n the power n minus n minus 2. Okay, this is 2. So this is the Calais theorem. So Calais theorem, we can find out how many spanning trees a tree can contain actually. Okay. So for example, we have a connected graph K4. Okay. K4 what shows? Basically K4 shows that we have 4 vertices. Okay. We have 4 vertices and this is a connected graph. Complete connected graph. Okay. So that means if we have this one, we have this one, we have this one, we have this one. Okay. Complete graph means you can visit each node while using just a single vertex. Okay. So this is the diagram for K4. And from this you can create 4 means 4 to the power 4 minus 2, that means 16. You can create 16 spanning tree. Okay. You can create 16 spanning tree. Okay. So I think that the topic is a little bit clear. Okay. Let's discuss the next topic. That was what was the next topic was. So topic was yeah, here it is. So basically what is radius is, you might have been seeing that in mathematics we haven't discussed about the radius, right? But it is kind of different in the graph. So basically we compare it as a, like if we have this tree, suppose we have a tree. Okay, we have this tree, we have this tree, we have this tree, and we have to find out we have to find out the radius. So this is 1, 2, 3 and 4. Right. Okay. So basically, this is also a tree. Okay. This is 6. The center of a tree is related to. We will be discussing about the radius. Radius in a tree. What is radius? So radius is minimum distance is called radius. First, I'll tell you the diameter. So basically, if I have to go 2 to 4, okay. So what would be the diameter between this both vertices? 2. 2. Number of edges, you have to just add number of edges, okay? So this is called what? If anybody have to find out the diameter of this particular given tree, so that would be tree 2, okay? Maximum distance is called diameter. Maximum distance is called diameter. So we have 1, 2, 1, 2, 1, 2. Say we have 2, 2, 2. Okay. So the maximum is 2. Okay. We cannot do like that from 6 to 4 because it's not possible, you know. We have to just start to traverse from the tree itself because no order is given. So in general, we consider it as a in order. Okay. So this diameter would be 2. Okay. Diameter would be 2. Diameter would be 2, okay. And then we have diameter and then we have radius. What is radius? So radius is what? Radius is inverse, you can say, of diameter. So radius would be the minimum distance. Like minimum distance, if I have to go 2 to 1, so that would be 1 edge is covering. I have to cover 1 edge, okay. So that means radius is 1, okay. So what is diameter, what is radius? This is super easy, right? And let's discuss about the third topic. This is called the distance. So distance is number of edges. Number of edges is called distance. Number of edges is called distance. Like if you have to find out distance, but you have to actually mention the node to find out the distance. 2 to 4 distance is 2. 2 to 6 is distance is 2. 2 to 1 is distance to 1. So like that distance is not, okay. Let's discuss next topic. A pendant vertex has degree 1. Okay. Forest is a collection of trees. Euler theorem gives number of spanning trees in complete graph. Cayley theorem. I have explained this thing. T to the power n equal n to the power n minus 2. Okay, this is called the Cayley's theorem. I will also write down over here if it is possible. T n, no, it is capital T. T n equal n to the power n minus 2. Okay, this is called the Cayley theorem. Okay. Okay, this is called the Cayley theorem. The order of complete graph K5 is not 5. Okay. Number of edges in K5 is 10. A graph with isolated vertices has a degree 0, okay? Because no vertex are there. A simple graph cannot contain loop. Loop only can contain a pseudo graph, okay? Even multigraph also doesn't contain, it cannot contain any loop, okay? Next question we have all the adjacency matrix represent what relation between vertices, okay? The directed graph edges are called arcs, okay? A diagraph means directed graph, okay? Here it is. Diagraph means directed graph. The degree of a vertex means incoming degree, okay? Out degree means outgoing degree. Sum of n degree equal to number of edges. A self group joins same vertex. Which graph has maximum possible edges complete graph? Okay. Two graphs are isomorphic if structurally identical. Graph coloring assigns colors to vertices. Chromatic number means minimum color required. Okay, that actually happened in the bipolar graph. Okay, a planar graph can be drawn without crossing edges. Okay, Q5 is a what? Q5 is a non-planar graph. Okay, K3 is what? Non-planar graph. BFS stands for breadth first search. Okay, DFS stands for depth first search. Okay, BFS uses BFS uses Q, okay. DFS generally uses star, okay. The complement of null graph is complete graph. If a tree with n vertices sum of degrees equal to 2 into n minus 2. Binary tree is a type of tree. Root node has no parent and leaf node has no children, okay. Internal nodes are nodes having at least one child. Leaf nodes also called as a external node, okay. Height of a tree means longest path from root to leaf, okay. This is called the height, and depth is what? Depth is basically it is specifying a specific vertex from the root itself. Like we have if we have vertex here A, okay. Let me also show you. If we have this, this, okay, this, this, okay, we have this tree over here. So if I find out height of a tree, that will be true. Okay. Height is basically generalized by different from root to leaf. Okay. So root to leaf we have to get as a cover. We are covering to edges actually edges. So height would be 2. Okay. But if we find out depth of what? Depth from this vertex. So that would be what? Depth from this vertex. That would be 2. Okay, so this is kind of ones between the vertices. Hope that makes sense. Okay. A complete binary tree has all labels filled except possibly last. First traversal basically first layer. Okay. In order traversal of binary is left, root, right. Post order left, root, left, right, root. Post means root right. Root will went to the right. In order means root will be in between left and right. Okay. The root of a spanning tree is optional. Okay. Connectivity is the maximum in complete graph. A brace in a graph theory is an S is removable disconnect a graph. Okay. A cut vertex is a vertex whose removal disconnect graph. Which graph always has a spanning tree? Connected graph has a spanning tree always. Okay, number of what degree vertex in a graph is always 1. A compared graph Kn is regular degree of n minus 1. Next question we have a regular graph means all vertices have same degree called the regular graph. Okay. The Peterson graph is non-planar. Euler's formula for planar graph is vertex minus edges plus f minus equal to okay. A graph with no cycle is called a cyclic graph. So there is a acyclic graph. Okay. A directed acyclic graph is abbreviated is DAG. The shortest path in unweighted graph is found by BFS. Minimum spanning tree does not contain cycle. Okay. Not minimum spanning tree or not a tree. Not a tree can contain any cycle. Okay. Since it is also a tree, so that's why it's also following the formula of the tree. Okay. The weight of MST is always minimum. Okay. Prims and Proscal algos are greedy algos for what? For the MST. MST stands for minimum spanning tree. Okay. If we don't know the full form. So, and DFS breadth first search, DFS depth first search. Okay, and then we have directed acyclic graph. Okay. A directed acyclic graph is abbreviated directed acyclic graph. Okay. And then MST minimum spanning tree. Okay. So basically, to find out minimum spanning tree, we have two algos, Prims and Kruskal algo. Okay. So these are the different algos. Which topic belongs to discrete mathematics? Yeah, all of these graphs let's get in mathematical logic. Okay. So all of these. So we have again done with 100 questions. So that was a part 2 of 100 questions. Basically, we'll be covering a lot of questions of discrete mathematics for semester 2 students. So that's all in this lecture. We'll be creating the video for the same stuff as well. So make sure first watch the video, the first one, that was the theory part. Okay, then come here and watch the video. Okay, so that's all in this lecture. See you in the next video. Till then, bye bye.